Okay, so here comes the very last chapter in HL, differential equations. For those of you, whether you are to study engineering, computer science, economics, or anything in science or business or commerce or engineering, you are going to use differential equations somewhere. So what is it? It is basically a type of equation that would involve the use of derivatives. Derivatives will be part of the equations, and you are going to solve this kind of equation using different method, whether it is by using integration or some other technique. But these equations are not that easy to integrate. It is not the same as the ones that you've seen in the past. But before we do that, we're going to look at what does it mean by a differential equations. We're going to look at one example here. In example number 1, when you are given a differential equations, they will usually involve y prime, and they will also sometimes involve x or y or other terms. And as we know, y prime indicates the slope. And we're going to calculate the slope for all possible values from -3 to +3, whether it is the x variable or the y variable. So we're going to start with something simple. Let's say I want to look at the slope when we have the point 1 and 1. When x equals 1 and y equals 1, what is the slope? Now looking at this equation here, when x equals 1 and y equals 1, the slope at this point equals 1. So I would expect a line going up this way in a 45-degree angle. But as I start to change the point with, let's say, 2 and 1, the slope will also be changing at the same time. When x equals 2 and y equals 1, this time we end up with slope equals 2. So we're going to see a steeper slope. And as you continue to change your point, you end up, let's say for 3 and 1, this time your slope at this point will now be at 3 and then at 4, and these points will continue to have deeper and deeper slope. And at the same time, using this concept, here is how I can generate the graph quickly. So you are going to see a trend of this line going up in a way like this. But when you were to look at points from other quadrants, let's say 1 and -1, this point will give us a negative slope. And then -2 for the slope, -3, -4, and same thing for these other points. So eventually, you're going to see lines in this quadrant going in that direction. Now I'm going to use the same concept and fill up the entire graph. -1 and 1 give us a slope of -1, and then this one -2 for the slope, -3 for the slope, -4 for the slope, -2, -4, -6, -8, and then for this one it would be -3, -6, -9, -12, very steep, -4. These lines will give us very deep slope. So here these are the slope, deeper slope. We're going to see lines going this way and going that way. So this is what we call the slope field for this differential equations. And I can actually find this general solution by solving this equation. dy dx equals xy. In order to solve this differential equations that involve derivatives, we're going to integrate this equation. But in order to integrate it, we need to separate the variable first. We want to keep the y on one side and x on the other side. What I'm going to do is to move this dx to the other side. Bring it with the x together. And at the same time, I'm going to move this y to the left hand side. So now, the y stay on the same side and the x stay on the same side. And as I integrate both sides at the same time, on the left hand side we integrate this with respect to y, and on the right hand side we integrate this with respect to x. And of course every integration will involve a constant term. So as I solve for y, single it out, we will end up with e to the power of 1/2 of x squared plus c, or more often, you will see the solution to a differential equation more like this instead, which turns out to be another constant multiply. So here I can call this constant something else, like a d. And this is the way that I can solve, this is how I can solve the differential equations.